We're going to go on to Java interface. And since an object has a blueprint of how it's going to look like a format, and this is defined in a class also has a format, and this is defined in an interface. So an interface is a blueprint of a class. So just as a class have blueprints for the object, an interface has the blueprint for a class. An interface can be used to define a set of methods which will be shared by a number of classes. So this also helps to pick out the commonality between classes and just helps them to use it as required instead of writing it differently, instead of writing it the same number of times in the same class. So you can define a set of methods that can be shared by a number of classes in an interface. An interface contains static, constant, and abstract methods. An interface does not have a method body. That is the difference. In an abstract class, you can put a method body, but in an interface, there is no method body. An interface can be used to achieve abstraction and multiple inheritance in Java. We said multiple inheritance is not supported, but an interface can inherit different interfaces, so which supports multiple inheritance per se in Java. An interface cannot be instantiated just like an abstract class, and a class that implements an interface must implement all the methods in that interface, just like an abstract class. In an interface, all the methods are public and abstract, and all the fields are public, static, and final, so you cannot have private fields. And also note that a class can implement more than one interface, provided it implements each method of the specified interface. So you have to take note, when a class is inheriting, it can only inherit one class, but it can implement different interfaces. So inherit is to extend is to inheritance, while implement is to interface. We'll see that when we are doing our example. So this is the example we're doing. We're creating an interface called bicycle and a class called car repair. So car repair would take in some of the methods defined in the bicycle interface. And we'll define that now. So we've created a car repair. We delete that. And we'll first create our interface. To create an interface, you right click on the source folder, click on new Java class. If you want it to be an interface, we'll name it bicycle. For this bicycle, we want some methods in it. So the first is the speed up, which is it takes in an increment and it is not defined. And then we have another one, void change here. Apply break. and we'll create the car repair, which will implement the bicycle. So implement bicycle. So to use an interface, use the implement keyword, and to use inheritance, you use the extend keyword. So we get an error here because we need to implement all the methods defined in the car repair class. So call it, we'll implement the methods, speed up, change gear, and apply brakes. So we'll put in some things here in our car repair that implements the bicycle class. Sorry, apologies. I think the class diagram is wrong. The interface was supposed to be for another bicycle called mountain bike. So apologies for that. This should be called mountain bike. So I'll create a new class called mountain bike. And I'll make it extend my bicycle, implement my bicycle interface. And I need to include all the methods that I've declared there. So in my mountain bicycle, I'm going to provide variables, speed and gear. And for my speed, I'm going to change my speed to be speed plus the increment. And for my change gear, I will just assign the new gear change to my gear. My gear will be equal to change. And to apply my brakes, I will just change my speed equals speed minus increment. I'll change this into decrement because we're decreasing speed. So we'll create a new mountain bike in our main class. And because part of the rules of our interface is that we cannot create a new bicycle. If you create a new bicycle, you need to implement all the methods which we don't want. And this is not really allowed in Java, so you need to create it from the mountain bike. So create a new mountain bike, and we'll say new mountain bike. And we'll just change the gear. Well, we need to identify our gear first. So put our gear as 15 we can do this because our variables were set to public, but if we change it to private, and we declare our getters and setters, we set our speed to, okay, we just speed equal, and in our main class we'll set our gear to 15. We don't need to. We'll set our gear to 15. We'll set our speed to 40, and then I'll apply the brakes, and I want to reduce my speed by 15, and I'll apply my gear as well. I'll change my gear to 20, and I would also speed up by 20. So just to be able to see what we've actually done, I'm going to put this in system.out.println. So new speed after brakes is plus speed, and in the change gear I'll say new gear is plus gear, and for speed up I'll say new speed after speed up is so if I run this now, you can see that my new speed after brakes is 25, my new gear is 20, and my new speed after speed up is 45. So because I implemented all these methods from the interface into my mountain bike, I could change it and do whatever I wanted to do with that method, and also call it as an object in my main class. So interface allows you to do that. And in a class, like I said, a class can extend another class. A class can implement an interface, and an interface can extend another interface. So this is what brings about multiple inheritance in Java. Because a class can implement multiple interfaces, and those interfaces can extend other interfaces, multiple inheritance is brought about. But it is not supported in class. You cannot extend more than one class because of ambiguity, so because of complexity. And it is supported in interface because there is no complexity, because you have to define all the interface that you've implemented. You have to define it in a class. You have to implement all the interface you've defined, in a class. So this is why multiple inheritance is supported in interfaces and not classes. We've got some differences between abstract class and abstract interface. In an abstract class, you can provide implementation of an interface. In an interface, you can't provide implementation of an abstract class. In an abstract class, you can have final, non-final, static, and non-static variables. However, in an interface, you can only have static and final variables. In an abstract class, you can have abstract and non-abstract methods, but in an interface, you can only have abstract, default, or static methods. You could only have abstract method, but in the new Java 8, Java 9, and Java 10 and upwards, you can have default and static methods. In an abstract class, there's no multiple inheritance, but in interface, there's multiple inheritance. In an abstract class, you can extend another Java class and implement multiple Java interfaces. But in interface, you can only extend Java interfaces, you can't extend Java classes. In an abstract class, you can have private, protected, public members, but in an interface, all your members are public by default. And for you to declare your abstract class, you need to use the abstract keyword in an interface. If you've created it from the IDE as an interface, the interface keyword is added for you. But if you want to change something to an interface, you have to put the interface keyword. And it's extended using the extend keyword. It is implemented using the implement keyword. Our last example that would show abstraction at interface, the relationship between them is this. It's a shape application. The shape class is abstract, and two shapes extend it, so rectangle and circle, and there's a shape dimension which prints out the dimension and also prints out what kind of shape it is, so which is an interface. So we'll create a shape which is an abstract class, a shape dimension which is an interface, and two subclasses which are rectangle and circle respectively. I'm going to create a shape class. And the shape dimension interface. So because maybe I did a mistake and I made it a class instead of an interface, I can just change it to the interface. And it changes automatically to an interface. And then two subclasses called rectangle and circle respectively. So in my shape dimension, I've got a method called dimension. So void dimension in length, in height, and in width. And I've got another method called print, which doesn't take in anything. I've got my shape. My shape would implement my shape dimension. We'll implement the interface. So we'll say implement shape dimension. Shape dimension. And let's not forget that my class is an abstract class. So because my class is an abstract class, I said earlier that if a class implements an interface, it needs to put in all the methods that were defined in the interface. It needs to implement all the methods. But because this is an abstract class, I can decide to only implement one. So for this, I'm going to implement my dimension. So I'll right click on my mouse and go to generate implementation, implement method, and I want to only implement the dimension. So you can, if you're implementing an interface in an abstract class, you can implement the kind of which method you want to implement. You don't have to implement everything. You can implement one or two or everything. It depends on you. So in my shape here, I am going to implement the dimension, and I'm just going to make it print out something. So I'll just print out the dimension. So height, plus height plus width plus width length plus length. And in my abstract class, I'm going to define an abstract method called area. So abstract void area should return a integer, which should take in two integers because we're doing area. So integer of length and integer of breadth. So it's an abstract method, keep testing and you don't implement anything. And also from our class diagram, we've got a variable called size. So integer size will make you protected. So we're going to implement this method in our rectangle shape. So we are going to extend the abstract class. So we say extend shape. And because we're extending an abstract class, we need to implement all the methods in an abstract class. So the area, and to also implement the method that we've not implemented in that interface. So because we've not implemented the print method in this shape class, we have to implement it in the rectangle class. So say enter implement methods, and you can see that it's asking you to implement all the other remaining methods. So we implement this method, and we'll just say in area equals length times breadth, and we'll say return area. Also ask it to print out area. And for our print, we'll just say something like rectangle has plus side. The side from the shape class. This side. We just say rectangle has side. And we're going to call our rectangle in our main class. So we'll go to our main class, create a new shape, so rectangle, new shape. Shape, new rectangle. And from our shape, we can define our side. So we'll say side is equal to 4, and then we can find the area. We need in two parameters, so I'm just going to put the length as 5 centimeter and the breadth as 6 centimeter, and we'll find shape dot dimension 5, 6, 5, 7, 6, and then shape dot print. So we'll run this. And as you can see, you'll see that our area is 30. And it prints out our height, width, and length. And it shows that a rectangle has 4 sides. So because this shape abstract class implements the shape dimension, rectangle had the ability to print out the implementation of what was defined in the interface, because the shape class did not define it, and it also had access to all the methods because we all know that they are related. Rectangle extends shape and shape implements the dimension. So an abstract can implement different interfaces. I can also implement my bicycle. Can implement my bicycle, but an interface can only extend another interface. Let's say bicycle. You can extend another interface, but we've only got 2 interfaces here now. So you can extend multiple interfaces, but an abstract class can extend only one class and implement multiple interfaces. It's kind of tricky, but with more studies and more practice, you'll be able to understand how abstraction and interfaces work in Java. That's the end of the class, and I'll take in any questions we've got, because we're almost late. Does anyone have any questions? You can apply inheritance to different real-life situations. So, for example, if I have different types of customers, or if it's a loan app, if you have an application that gives out loan, you can create different kinds of classes for that loan. So your loan will be your parent class, and then you can have mortgage loan, car loan, overdraft, business loan, which would have similar attributes, but would also be specific in different ways, like maybe when you're calculating your interest, or maybe when you're calculating the amount you can give out, the maximum amount, the minimum amount. So you can apply inheritance to that one. You can apply abstraction as well to that one, because you have a common class, which is your loan, and then you can separate them into different kinds of loan, like mortgage, car, overdraft. Yeah, that is one real life experiment you can apply this to. Object through a constructor and then pass it in a method as a parameter. So your constructor has to be instantiated. You need to create an object first using a constructor, and then use that object as a parameter in a method. So I give an example here. If you see the car repair, it takes in a parameter of a car, but this car needs to be instantiated first. So if we go to our main class, we see that the car was first instantiated, and then the repair car now took in the car that was instantiated by a constructor. This Audi has a default constructor. We did not define a constructor for it, so Java gave it a default constructor. So this Audi has a default constructor, and a car object was created from the Audi constructor.
This is really good, actually. So I was telling this guy, everyone, that this is very, very important. This particular class is very, very important, because if you go for an interview, this is one of the questions. If you go for 10 interviews, actually, I bet you 7 out of 10, they will ask you about principles of object-oriented programming, and then you have to be talking about polymorphism, inheritance, abstractions. So this is very, very important. And if you could watch this video again, it will really be good. And also for those guys also that are going to be doing software testing, this is basis, to be honest. So I'll be doing the software testing from next week, Saturday, and this has really done a great job for me actually. So I will be taking it as assumption that most people already know, even though I will still start it like kind of from the very basis, to be honest. But this is really, really good. I sat here and I really, all those examples that you went through was really good. But bear in mind, there are some people that it's going to be like magic to them, because it seems that you know it so well. But I can only advise them to watch the video again, to be honest, because it will take time for this to sink in. I can tell you that. So it will take time for you to sink in. And for people that are hearing polymorphism for the first time, to be honest, you just need to continually watch the video and do it by yourself. Basically, just get your hand in there and do it. It will not sound right at the first instance, but I can assure you, once you get the logic and how it works, it will be easy for you. And to be honest, even it's possible that you might not get everything. Yeah, you might not get everything, but it will be good for you to get at least something, so that when the interview comes, or if you are going for an interview, you actually know what they are saying. It doesn't look new to you. And one thing that Ike has also done is to put some examples that kind of so simple, like using cars, using animals, using different things, so which are you can actually relate with, using shapes and arithmetics. So it is different than using something that you are not familiar with. But for those simple examples, you could actually reason with that. You can understand for what he's saying. So I can say well done to you, Ike. You've done very well, and also to Oyin also for taking the other class. So thank you so much.
There are no further questions. I'll end this class and I'll see you guys next week.